Hi friends, welcome to this series Understanding Operating Systems, one concept at a time. To ensure that topics about the operating system are all covered, we just follow the syllabus for second year computer science, information science, AIML students under Karnataka's VTU, just as a reference. So let's dive into the operating system concepts. I am Sandeep, working as a Dean R&D professor in ISC department in Sri Krishna Institute of Technology, Bengaluru, welcoming you to this series. So let's begin our first episode, get into what operating system is, just an introduction to that. An operating system is a fundamental software that manages computer hardware and software resources. It's an interface between the user and the computer hardware. It provides essential services like memory management, file management, and process management, etc. So the image shows here the hardware we have at the bottom, and on the top we have a user. When the computing system began, it began in the laboratory of electronics, and it started with something digital electronics, gates, then next versions like multiplexers, adders, subtractors, decoders, and then we went on and created something called a processor. A processor works at a digital level, that means works in binary system. It understands a language of only zeros and ones. And if we want to make our system work for us, then we have to go down to its level and make it work in, and we need to communicate with the processor in zeros and ones, and that is almost an impossible with the next generation of processors. At 8085 level, it was somewhat possible to work at assembly level, but later on, it's almost impossible to work even at assembly level. We need a high level versions. So the user started working with high level versions called applications, and these applications are built to make some actions possible, but these applications are also built at a higher abstraction, and to make sure that the applications interact with the hardware the proper way in spite of high abstraction, what we require is one middle layer which we call an operating system. It's an interface between the user and the computer hardware. So user no longer needs to understand what the hardware is, what the hardware features are, what the hardware can do, and all details. They can be hidden from the user, and this hiding is done through a layer called operating systems. So What the operating system can do, just look at the list of the various functionalities performed by the operating system. It takes care of what we call process management. The code, what we write, is called a program as long as it is there in the back end, that is a secondary memory. But once it becomes active, then the same program comes onto the main memory, and that will become a process. So which program has to come to the main memory, which program should run at any given time, or which process should run at any given time, and all that are taken care by the component called process management. Then we have a memory. That's mainly we are dealing here with the primary memory, or the memory which is there on the motherboard, which we often call RAM. So it's a faster memory compared to the secondary memory, the which is of a bigger size but a slower one. So coming to the memory management, it deals with the limited memory we have on the motherboard, the RAM, and we would like to make sure that this limited memory is most effectively utilized for multi-process environment and all that. So how the memory can be efficiently utilized is taken care by the component memory management. Then a large amount of data and the programs we need to store, which is not possible to be stored on the primary memory, which basically is a volatile one. We need some non-volatile memory of large size. So it may be a hard disk or a similar one. So how the programs or the data are stored on the hard disk, they are stored in the form of files, and how they are stored so that the storage is done efficiently, nothing is wasted there. At the same time, we will be able to store and retrieve those files more effectively at a faster rate. So all these activities are taken care by the component storage management. Yes, anywhere you talk of security and protection is one of the key issues to be taken care. So when a program or the data of one user has on the memory, maybe primary memory or on the secondary memory, we must ensure that others, maybe other process on the main memory or other users should not misuse the data. So for that, some sort of security and protection is required, and that is taken care by the component of the operating system, which we call the security and protection management. Once we are working on the recent systems, then we are connecting many devices to our system. It may be a keyboard, it may be a mouse, it may be any other devices. Now we are making the mobile phones connected to the systems. So many things, So to make sure that all the devices are working in sync with the system and without any malfunctioning, everything should work smoothly. So to ensure that there is a component device management, then to make sure that user has got a easy access with the system with a minimum headache. So to ensure that easier access to the user is made available. So there was one time when everything was done with connecting wires directly onto the chips. But later we have motherboard, we have keyboard, mouse, and all that displays. So these are added for making the human activity simpler so that human can concentrate more on building higher versions of the system than wasting time on basic activities like connecting, typing, and all that. So uh, with time, the human and computer interaction is becoming more and more sophisticated, and for that we need better user interface management, and that's taken care by this part of the operating system. Then finally we have multiple systems connected with each other. So we have a network of systems, and how we ensure that this whole network of the systems work as one unit. So we need the operating system to have some features that will help in managing these all activities of interconnecting the network and all that. Yeah, of course, looks very vague if we just keep talking in a computer language. So let's come down and see what exactly we wanted to tell as an example. So let's take the old example we had in our introduction session. That's a restaurant example. So the central column is talking about the various operating system functions. The left one talks about the analogies which holds for any restaurant, and the right side column talks about the actual things we are going to study in the coming sessions of this series. So we begin with process management. When we say process management in our restaurant version, it is trying to manage all the cooking orders at the kitchen simultaneously. When multiple orders come to the kitchen, how they are managed, because we have limited resources, we have limited resources, and with that limited resources we should be able to make sure that all the orders are taken care. So on other side in our computer version, it is like multiple processes are running on a single processor environment. Then at any given time only one process should be active, so the processor will work on it, and all other processes should be inactive. So how to keep one process active and others inactive, and once one process changes its state from active to inactive, then who else should become active next? So that's the scheduling and all that. So many issues are related with working with a multi-process environment. It may be a single processor or multiple processors, parallel computing. Many issues are involved in that. So all the issues related with the process and how to manage them, it all is part of the process management of operating system. The second part is about memory management. So looking at the restaurant side, there are limited stores available. If you move out, there are limited tables available. So how do you manage all this and still make sure that each of the customer is serviced in a earliest and make each customer happy, satisfied, and all that. So we have limited resources and how to make sure that with the limited resources, all activities are taken up. So in our computer world, we have limited size of the RAM and make sure that the limited size of the RAM should be made available to all the programs that want to become a process and somehow manage the show and make sure that none of the users are able to understand that inside so much of activities are going on. So each user will be thinking that the whole memory is available to the user himself or herself. That's how a illusion is created. Same way in the process management also, that whole system is available to my program only. That's how I, as a user, understand it. So this whole illusion is created by the operating system under the memory management. Then we have file management. It's in the case of restaurant, it's organizing the recipe books and ingredients and orders. So where do you keep them so that it is easy to identify or easy to search the books or the ingredients at the earliest so that the whole activity will not stop for anything which is missing or difficult in searching and all that. So this whole thing is what we do in this restaurant system. But in our computer world, we do have files, and these files are organized under various folders inside the disk. So this folder file or this organization, everything is an illusion to the human. But in reality, what actually happens inside a system, it's very well managed by what we call file system. Then we have device management under the restaurant version. It is coordinating the waiters, ovens, dishwashers, and tables and all that. So making the whole system work in sync so that a whole activity is done more efficiently in a very well way. So in our computing world, it's input output devices like keyboard, mouse, the monitor, and other devices being connected to our system. So how do they manage how the interaction takes place, what language they use to interact? Yeah, this all things are created through some protocols, and these protocols will ensure that everything works smoothly. So that's the component of device management. Then we have a user interface like we interacting with the customer in the restaurant, the waiters, the menus will help the customer to know what the dishes are available and interacting with the waiter, the customers can understand the various dishes available, their quality, their taste, and all that. So menu will help that. So without a menu and without discussion with waiter, it becomes impossible for any customer to give an order. So we need a well documented menu, and then there should be a proper guidance from the waiter. Only then the whole restaurant system will work smoothly, customer will be satisfied, and that way. So that's a user interface, and in our computing world, we can have the graphic user interface or other systems so that human can interact with the machine. So it may be graphic user. That means we can make use of mouse and touch screen and all that, or even we can make use of the uh, keyboard and type all the commands. So command line interface, that's a user interface. Then looking about the security and access, getting into the restaurant, in the kitchen only chefs are allowed, others are not allowed, so that others don't go in and disturb the environment there, don't create any problems, so they don't mix anything with the dishes and all that. So the security is very much important there. So that means the quality of the food has to be well maintained. So in order to have that, only thing is only a proper well-trained chef has to attend for any given item, not others to interact or others to interfere and all that. So this security access and all that have to be taken care. On the other side, when customer is given with a bill, it should be made visible only to the customer, not should not be put it on the notice board like thing. So it should make sure that access is only to the customer or the one who is supposed to pay the bill, not to anyone else and all that. So on the computer world, so we want to prevent unauthorized access of any of the resources, maybe files, maybe process or anything. So to ensure that unauthorized access is not allowed, proper security measures have to be taken. So authentication and all that are required for access control and all that. So that is taken care by the component security and access of the operating system. And finally, coming to the networking part of the operating system, in the restaurant version, we can talk about online orders. Then we are taking care about the supply chain, getting the orders, and then purchasing the raw materials, and then delivering the prepared items to the remote customers and all that. So these all are taken care by the networking, so supply chain. So in our computer world, supply chain activity is taken care by the internet and interconnections of the systems. So we need some part of operating system that manages this internet or data connections and provide proper protocols, more proper languages to speak with one another and all that. So that's some analogy about our operating system. If we look at our common experience, Then I can quote a restaurant example and try to connect the various functionalities of the operating system with what happens at a restaurant. So that's all about this various components of the operating systems and its equivalent analogy in a restaurant. So from next session onwards, we jump into various activities, various details about the operating systems, and please keep watching. And if we feel that the sessions are of any use, please don't forget to like and press the bell button, subscribe the channel. Thank you.